All right, so we learned about z-scores yesterday, and z-scores are going to tell us who did better. In a lot of cases where you're comparing things that might be similar but not the exact same, like this exact scenario here, which says when Michael Jordan played his final year of college basketball, he scored 19.6 points per game. That was his average, his mean. That year, the average points scored for player was 8.2, and the standard deviation was 4.1. When Zion Williamson finished his final and only year of college, played after his freshman year, he went out. Says he was averaging or scoring 22.6 points per game, so he was averaging more than Michael Jordan was. That year, the average points scored per player was 7.7, and standard deviation was 5.8. And so it says if by just using their z-scores and comparing points per game, who was more dominant of a scorer? Okay, so we can answer this by calculating their z-scores. So let's start with Michael Jordan's. His z-score would be, remember you take his data point, which is 19.6. You subtract the average amount scored, so in this case, 8.2, and divide it by the standard deviation. And so, throw that in a calculator, see what it comes out to be. So the 19.6 minus the 8.2 is 11.4, and then I divide that by 4.1. So his z-score, 2.78, which again, just to put it into perspective, remember, when you start getting to above 2 and close to 3 z-scores, if you're above that third z-score, you're in that third tier of that empirical rule, which means you're better than 99.7, 99.85 of those percent of the people. So this is a really good. It means he was better than nearly everybody playing basketball that year, scoring more than them. And then you had Zion Williamson. He averaged 22.6. Points per player were 7.7 that year. And standard deviation was higher, it was 5.8. So we do our same calculation here, 22.6 minus 7.7. And then we divide that by 5.8. And his z-score is 2.57. And so these things are always kind of interesting because, at least to me anyway, people love to argue, which basketball player was better, who did this or that or whatever. And a lot of times people compare things like average points per game, but you don't take into account the fact that, these two players played 20 plus years apart, and the game changes, the way teams can play defense, rules change, stuff like that. And so you got to take all that kind of stuff into account. This is a way to kind of do that. It allows you to compare how were they compared to all the other players playing at the same time. And you can see, okay, yeah, he was a little bit more of a dominant scorer. Now, they're both awesome. Both of these are way above the average, way above the mean, several over 2.5 standard deviations each. But it gives you a cool kind of thing to be able to compare two things in a statistically correct way. So z-score is pretty neat. Definitely something that you'll use if you ever look into any statistical type analysis stuff.